Alright, in this video I'm going to walk you through a very basic yet very powerful use of indicator functions. Right? What I have here, I'm going to offer two examples in this video. One of them is using just one variable, the random variable, the other one is using two. What I have here, I have generated a random number from normal distribution with average of 10 and sigma of 3. If I click on distribution right here, you see that it is normal with a mean of 10 and sigma of 3. Now, let's say I'm interested in knowing the probability that this random number is bigger than or equal to 11. All right. Well, I can play with this bar right here and put it on 11, and it was on 11, right? 11, and make sure the other one is at this one, the other one. This one, all right, this one is all the way at the end, and that probability right there is this area, and that one is given right here, 36.9%, almost 37%. So if someone asks you what is the probability that normal of 10 and 3 is bigger than or equal to 11, the answer is 36.9. All right, not a big deal, easy peasy. All right, now can we solve it slightly differently? Yes, and we are going to use this very trivial example to introduce the concept of indicator functions. I'm going to say, you know what, in another cell, I'm going to say equal to if this cell on top, all right, that normal, is bigger than or equal to 11, give me 1, otherwise give me 0. What this cell does, it is going to turn to 1 every time that cell above normal is bigger than or equal to 11, and it's going to be 0 every time that is less than 11. So let's just experiment a little bit. Right now, this one is less than 11, this cell is 0. F9, right now this one is 16, bigger than 11, this one is 1. Next, I'm going to tell at risk, hey, go keep track of that output cell. I'm going to call that indicator 1. All right? Now, if I run simulation, at risk is going to keep track of this cell right here. All right, I'm going to run 10,000 iterations. Not a big deal. Let's run it. All right, done. And let's look at distribution of this cell, output cell that I have. I'm going to go to Explore, Browse Results, and right now you see that it's not a big surprise. There are only two values with positive probabilities, 0 and 1, and that is because of the way I have defined this cell. I have defined it to take only 0 or 1, right? And every time that cell is 1, that blue cell right there, normal, is bigger than or equal to 11, right? So if I find percentage of time that this cell is 1, that is equivalent to finding percentage of time or probability that normal is bigger than or equal to 11. And that probability is right here. See, height of 1 is 36.9. You can figure that out, and you know what, you can put these bars around that bar of 1, and you are going to see that you get probability 36.9. all right, that is one very powerful use of indicator functions. Now in this case we didn't need this. Why? Because we could have easily found that using that right there, 36.9 number that I have on top right here, right? So but let's go to next function, next example, and see how else we can use this. Here I have two different random numbers. One of them is a normal of 10 and 3. The other one is a uniform of 2 and 15, meaning uniform between 2 and 15. If you want to see shape of this one, uniform of 2 and 15 is going to be, well, uniform between 2 and 15 right there. I want to know what is the probability that normal of 10 and 3 is bigger than or equal to uniform of 2 and 15. All right, that's what I'm looking for. Well, now this is not so easy, right? It's not so easy to you know what, let's be a little more adventurous and say this. All right, it doesn't make much of a difference, but let's try this. What is the probability that normal is less than uniform? All right, when do we use this? Well, here's one very trivial example. What if demand for a product is normal, the other one is uniform, and you want to know when or what is the fraction of time or probability that demand for one is going to be less than the other one, right? There are lots of situations with this kind of questions we want to answer, and here's one very simple way of addressing it. Again, there's nothing new here. I'm going to say this is equal to if that normal right there is less than or equal to that uniform right there, then give me 1. Whatever is desired for me, whatever I'm trying to measure its probability, I'm going to put it in my if statement, that clause, if clause, and then give me 1, otherwise give me 0. All right. And right now, for example, uniform is more than normal, it gives me 1. Uniform is more than normal, gives me 1. Uniform, there we go. Normal is bigger than uniform, then I'm getting 0. Then I'm going to, next, I'm going to define this as my output, and output is going to be normal less than uniform. Let's just keep it that way. All right, well, you know what, let me do it right. Okay, uniform of 2 and 15, fine. All right, next I'm going to run this. Every time uniform is bigger than normal, that cell turns to 1. Now I'm going to look at probability that, or height of bar on top of number 1. All right, so let's go to explore, browse results. There you go. As a matter of fact, it's actually pretty similar, pretty close to what we had earlier, not exactly the same. So that height is almost 40%. If you want to find exact number, is going to be right there, 39.1%. There's 39.1% chance that that uniform of 2 and 15 is going to be bigger than normal of 10 and 3. Here's added bonus, because this is 0, Bernoulli, all right? So its mean is going to be equal to height of a bar on top of 1, right? So because how do we find average? Average is equal to 0 times probability of 0, which is going to be equal to 0, plus 1 times probability of 1, which is going to be equal to probability of 1. And so then mean that I have right there is 39.5 is the answer as well. I can get that probability using risk mean as well. All right, so I'm going to get that 39.1, which is rounded number. I'm going to get that using risk mean as well. So that probability, technically probability is equal to risk mean of that cell. All right, and that is going to be 39.1. This is the same as what we did, what we had earlier. All right, and if I want to make this percentage and all of the fanciness, there you go, you have it. Now remember this is going to be part of your moving on. It's going to be part of a lot of calculations and a lot of calculations that we are going to do in this class.